Hello everybody, welcome to this new video from Guidancee Education channel. We are continuing class 12 physics chapter 2, electrostatic potential and capacitance. Under that we will be discussing capacitance of a capacitor with dielectric medium in between the two plates. We have already discussed capacitance, potential difference, electric field and potential energy in the capacitor with no dielectric medium. In this video, we will discuss these quantities for a capacitor with dielectric medium. How this dielectric medium affects the magnitudes of these quantities. But before we start the video, please watch the video completely so that you get all points cleared. And if you think it is useful, do like the video, share the video with your friends and also leave your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, please support me by subscribing. Press the bell button and all button for notification of more videos like this. Thank you very much. I am ananthavalli. Come, let us start the video. These are the two plates of the parallel plate capacitor with the two leads. When the capacitor is charged, plate number 1 gets positively charged and plate number 2 gets negatively charged. Plate number 2 develops a charge density equal to negative sigma and plate number 1 develops a charge density equal to positive sigma. V0 is the potential difference between the two plates. Please note that there is no intervening dielectric medium in between the two plates. The two plates are separated by a distance d. In reality, this distance is very small. Here I have shown it a little big for the sake of convenience in explanation. As there is a potential difference between the two plates, an electric field is set up between the plates and the direction of the electric field is from positive plate to the negative plate. We use the symbol E0 for the electric field. These quantities are all without dielectric medium in between the two plates. We have already derived a formula for capacitance in the case of a capacitor without dielectric medium. It is equal to C0 is equal to epsilon naught A upon D. Epsilon naught is the permittivity of space or vacuum. There is no dielectric medium there. Similarly, V0, the initial potential difference, that is without dielectric medium, is equal to E0 into D. E0, the electric field, is equal to sigma upon epsilon naught, which is equal to Q by A into epsilon naught. Q by A is equal to charge density sigma. Let me clarify. C0, V0 and E0 are the corresponding symbols for capacitance, potential difference and electric field of the capacitor without dielectric medium. Now we will proceed to see what happens to these quantities when a dielectric medium is introduced in between the two plates. There will be a large number of molecules in the dielectric medium. I have shown here only a few, only to tell you what happens to these molecules when it is kept in the electric field between the two plates. The molecules undergo polarization. That is, within the molecules there is charge separation. The positive center of the molecule, that is the nuclei, get shifted along the direction of the electric field and center of the negative charge, that is electrons, get shifted in the opposite direction of the electric field. The side of the dielectric medium nearer the negative plate develops positive charge density and the opposite side of the dielectric medium nearer the positive plate develops negative charge density. These charge densities are due to polarization of the dielectric medium. We will mark it as positive sigma P. P stands for polarization. On the other side, we will mark it as negative sigma P. Because of this charge density due to polarization, the net charge density at the two plates change. That is, at the negative plate, the new charge density will be negative sigma plus positive sigma P. On the positive plate, the net charge density will be positive sigma minus sigma P. I have noted the net charge density there for the two plates. The magnitude of sigma is the same. The magnitude of sigma P also is the same. Their sign only changes. So for further derivation, we can choose any one of these charge density expression. We will choose the second one. We will see the expression for electric field with the dielectric in the medium. E naught is equal to sigma upon epsilon naught. Now E is equal to sigma minus sigma P by epsilon naught. So from this we understand E is smaller than E naught. That is, with dielectric medium in between the two plates, electric field gets reduced. This reduction in the electric field is caused by sigma P, that is charge density due to polarization. Polarization depends upon the electric field E naught. For the same electric field, the polarization depends upon the dielectric medium. Different dielectric media like glass, paper, mica, etc. get polarized to different extents by the same electric field. Whatever may be the value of sigma P, sigma minus sigma P is always proportional to sigma. That is the initial charge density. That is charge density without dielectric medium. I will explain. Sigma P is less than sigma. But when sigma increases, sigma P also will increase because the electric field increases. So the magnitude of sigma minus sigma P will depend upon sigma. So that is why we say sigma minus sigma P is proportional to sigma. But we want to find out the value of sigma P. So we have to convert this into equal to. So for that we use a constant, proportionality constant. That is sigma minus sigma P is equal to 1 by K multiplied by sigma. What is this K? K is the dielectric constant of the dielectric medium. It is also known as epsilon R. R stands for relative electrical permittivity. That is relative electric permittivity of the dielectric medium. That value is always greater than 1. So 1 by K will always be a fraction. So from this you can understand the charge density with a dielectric medium in between the plates of the parallel plate capacitor will be less than the initial charge density. Substituting for sigma minus sigma P in the equation for electric field, it becomes E is equal to 1 upon K epsilon naught sigma equal to sigma by K epsilon naught. So this equation proves that E is less than initial electric field E naught. That is electric field without dielectric medium. Now potential difference V is equal to ED. It becomes sigma by K epsilon naught into D. Substituting for sigma, this equation becomes Q upon A K epsilon naught D. Q is the charge on the capacitor. Comparing potential difference of the capacitor with dielectric with initial potential difference V naught, we find that V is smaller than V naught. We have already seen that the electric field also gets reduced when a dielectric is used. So, the potential difference also decreases with dielectric in between the plates of the parallel plate capacitor. So, when dielectric medium is used in the parallel plate capacitor, electric field as well as potential difference reduces. What about capacitance? C. Capacitance is equal to Q upon V. Substituting for V, we get the quantity as C is equal to Q upon A K epsilon naught into D. I'm sorry, this D should be in the denominator. This whole quantity is for potential difference, V. Q in the numerator and denominator get cancelled and the equation becomes Ka epsilon naught upon D, which is equal to K multiplied by C naught, because A epsilon naught upon D is equal to C naught. So here C is greater than C naught. That is, capacitance with dielectric is greater than capacitance without dielectric. When a dielectric is introduced between the capacitor plates, the capacitance increases by K times. K is a relative electric permittivity of the dielectric medium. For example, if a dielectric with relative electric permittivity equal to 3 is used in the capacitor, then the capacitance of that capacitor will increase by 3 times its capacitance without the dielectric medium. From the formula C is equal to K C naught, we can define K. K is the ratio of the capacitance of a capacitor with dielectric medium to the capacitance of the same capacitor without dielectric medium. That is, C upon C naught is equal to K. Finally, before we wind up the video, we will also see how the potential energy stored in the capacitor is changed when there is a dielectric medium. Recall the formula for potential energy. Potential energy U is equal to C V square upon 2. So, potential energy is directly proportional to capacitance. We have seen that when a dielectric medium is used, capacitance increases. Therefore, potential energy also increases when a dielectric medium is used. If you think the video was useful, do like the video, share the video with your friends, and also leave your feedbacks as comments in the comment box. If you have not yet subscribed my channel, do support me by subscribing my channel. Press the bell button and all button for notification of more videos like this. Thank you very much. We will meet in the next video with another important topic like this. Till then, bye. Take care.